What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm back again to drop some more math jewels. In this video, I want to show you how to solve systems of equations using elimination method. Okay, so we've had the substitution method, we've had now the elimination method. Okay, there's one more method, which is the graphical method, but we we'll have to do a different type of video on that one. Maybe I'll do that one on a screencast so that you can actually see the graph. So I have 3x plus 3y equals 27. All right. And then I have x minus 3y equals negative 11. All right. So with the elimination method, what we're going to do is we're going to combine the two equations to eliminate one of the variables, solve for the other variable, and then go back and use substitution. So here, if you notice, I have positive 3y and I have a negative 3y. So if I add these equations, right? So basically what I'm doing is I'm adding these two equations like this, right? So if I add 3x plus 1x, I get 4x. Well, if I add 3y plus negative 3y, they will cancel. So there's nothing there. And then 27 plus negative 11, that gives me 16. All right, so if you notice, I have 4x equals 16. All I did was add the two equations. Well, if 4x equals 16, let's write that a little closer. I can divide by 4, and x equals 4. All right, so if x equals 4, now I have to plug that in to one of these equations, and I will find out what y is. So I'm going to actually plug it into the first equation. So 3 times 4 plus 3y equals 27. That gives me 12. All right, subtract 12, 3y equals 15. Divided by 3, y equals 5. All right, so y equals 5 right there. So x equals 4, y equals 5. That means that our solution is the ordered pair 4, 5. So that means that these two lines will intersect at the ordered pair 4, 5. You can always plug in your value of x and y, and when you calculate it, 3 times 4 is 12. 3 times 5 is 15. 12 plus 15 is 27. And the same thing will work out here. 5 minus 3 times 4, so 5 minus 12. I'm sorry, 4 minus 3 times 5. I'm sorry. So 4 minus 15 does equal negative 11. Okay, so that's our first example. Let's get right into the next example. And I'm going to make sure that I change this to example 2 because I was just looking at the last video that I made and I did not change the numbers when I did the second example. But, you know, I don't I don't try to make perfect videos. I want you to see the real authentic me. Example 2, 6x plus 5y equals 39. 3x plus 5y equals 27. All right, so now in order to eliminate one of the variables, there's a couple ways that we can do this. But in order to eliminate it, our goal is to get opposites. So I have positive 5y. I want to get negative 5y. Here I have 6x. I would want to get negative 6x. But it's easier to just do the 5y. So what I want to do is I want to take the first one. 6x plus 5y equals 39. And then I want to actually multiply this second one by 0. So I'm going to multiply this entire second equation. I'm sorry, not by 0, by negative 1. Okay, so negative 1 times 3x is negative 3x. Negative 1 times 5y is negative 5y. And then negative 27. Negative 1 times 27 is negative 27. Now I'm going to add them together. Well, 6x plus 3x, I'm sorry, 6x plus negative 3x is just 3x. 5y plus negative 5y, they cancel, give you 0. 39 minus 27 is 12. So I have 3x equals 12. Well, divide both sides by 3, and x equals 4. All right. I still have to substitute that x into the other equation now, one of the other equations. So what I'm going to do, I'm going to say 6 times 4. So I'm going to plug it into the first one. So 6 times 4 plus 5y equals 39. That gives me 24 plus 5y equals 39. Subtract 24, subtract 24. 5y equals 15. And if I divide by 5 there, divide by 5 there, y equals 3. All right, so my ordered pair of intersection is 4, 3. Okay, that's the solution, the ordered pair 4, 3. Remember, a system of equations, we're trying to find out where they intersect. Let's do example 3. All right, example 3. Now this one's a little more tedious. 6x plus 4y equals 42. And then we have negative 3x plus 3y equals negative 6. Now, this one's a little trickier because if I want to get opposites in regards to the variables to eliminate them, I have to multiply one of these equations by something else. So I'm going to bring down the first one, 6x plus 4y equal 42. Now I need to either get, for me, I would multiply the second one by 2 because 2 times negative 3x gives me negative 6x. All right, so I'm going to multiply the second one by 2 this time. All right, so 2 times negative 3x gives me negative 6x. 2 times 3y gives me 6y. And 2 times negative 6 gives me negative 12. Okay, now I can add these two equations together. Well, 6x minus 6x, or 6x plus negative 6x, it cancels. 4y plus 6y is 10y. 42 plus negative 12 is 30. Okay? Divide by 10, divide by 10. Y equals 3. All right? Y equals 3. And then now I plug that in. So I'm going to say, let's plug it into the first one. So 6x plus 4 times 3 equals 42. 6x plus 12 equals 42. Minus 12 minus 12. 6x equals 30. Divide by 6, divide by 6. X equals 5. So my ordered pair is 5, 3. That means that these two lines intersect at the ordered pair 5, 3. All right, let's do one last example. Now, this example, as I say, I try to remind you all that I like to present the different scenarios of problems that you might see, because when you're working on these, sometimes teachers give out problems and they want to challenge you. And it may not be one of the problems. They may not always give you an example in class to show you how you're going to have to do the ones at home. So 6x minus 3y equals 15. And then we have 7x plus 4y equals 10. All right, now this one, in order to be able to eliminate one of the variables, we're going to actually have to multiply both equations by a value. Okay, so what I want to do is I want to go ahead and try to eliminate the y's because this one is already negative and this one is positive. But in order to do that, I'll have to get a 12 here. So I have to actually multiply this equation by 4, and then I have to multiply this one by 3. Okay? So watch, even though I put it on the right side because of space, watch how this goes. So if I multiply 4, I got to distribute it to everything. So I get 6x times 4, which is 24x minus 12y equal 60. Okay? And then here I get 7x times 3, which is 21x plus 12y equal 30. Okay? So I did this, I multiplied these by those two numbers simply because I wanted to get the variable to be able to eliminate the y. Now I can add these together. 24x plus 21x is 45x. Those are opposites, so they will be eliminated. 60 plus 30 is 90. Now, 45x equals 90. 45, we divide by that, and then we get x equals 2. Okay? So, I still need to substitute that into the original equations. I don't want to worry about the 4, this part right here where I multiplied them by the 4 and the 3. So I'm going to say 6 times 2 minus 3y equal 15. So 12 minus 3y equal 15. Subtract 12, and then negative 3y equals 15 minus 12 is 3. Divide by negative 3, y equals negative 1. So my ordered pair of intersection is 2, negative 1. That means that these two lines will intersect at the ordered pair 2, negative 1. Now, if I wanted to check to see if this is correct, I can substitute these into the original equations. All right. So, I know this video was long. You may have to pause it, rewind it, and go back and look at the examples. But I wanted to make sure that I show you the different possible systems of equations that you might see, or the type of problems that you might see when you have to solve a system using elimination. Thank you so much for watching. Please, if you're not subscribing, hit that subscribe button right now and go share it with a friend. Follow me on Instagram as well at younggurus_math tutoring. I'm also on LinkedIn, Facebook, Young Gurus Math Tutoring. On LinkedIn, I'm actually listed under my government name, Dana Harris. But thank you so much for watching and supporting my vision of helping students all over the world understand and learn mathematics and be able to do it independently. Thank you so much. Remember, I still have the solution to your math problems.